Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will be trying to explain to you where we get the compound angle formulas from, which is the formula which has the sum or difference of trigonometric ratios, and plus where do we get the double angle formulas from. So to be able to understand this particular concept, I would want you to first of all understand how we made this particular diagram, where this is a side of a unit length and I divide this angle into two right angle triangles. So if you can see, I made a line from here and then a perpendicular to that, so that this is a right angle triangle with the angle P. And then this side and this side makes another right angle triangle with angle A. One more thing, if I will continue this diagram and make two perpendiculars here, then I would be able to realize that if this angle is A, this angle must be 90 minus A. And if this angle is 90 minus A and this is 90 degrees, and whole angle this would be 180 degrees. So if I subtract 90 and 90 minus A from 180, I will get this angle which will be equal to A. So I have sort of identified that this is angle A and this is a right angle triangle, and this is angle B forming another right angle triangle. One thing important about this right angle triangle is that I've taken its hypotenuse to be 1 unit. And then I've continued this diagram by making another right angle triangle and identifying that this angle is equal to this angle. The other thing I would want you to know for sure, that if you have a hypotenuse, you can find out the base by using the cos ratio. So the base is going to be h cos theta. You can find the perpendicular by using sine ratio. Somehow the perpendicular is going to be h sine theta. What I really want you to note over here is that if you know hypotenuse and you know an angle of a right angle triangle, then the side right next to the angle is going to be hypotenuse times cos theta, and the side which is right opposite to the angle is going to be hypotenuse times sine theta. So once we have identified that, we can also sort of note here that if this is 1, this is angle B, and this is a right angle triangle, then the side that is next to the angle is going to be 1 into cos of B, hence this is going to be cos B. And the side that's opposite to the angle is going to be 1 into sine B. That means this side is equal to sine B. So keep in mind, I have identified this length as cos B and I have identified this length as sine B. Now moving on, look at this right angle triangle, where now this side that I found as the base of the previous triangle is now the hypotenuse of this new triangle. So if I want to find this length, this is going to be hypotenuse times cos of this angle. So it will be cos B cos A. And this side is going to be hypotenuse times sine of this angle. That means cos B sine A. Now, considering this particular right angle triangle, if we know that this side is sine B and this is A, then the side that is next to the angle, that's going to be hypotenuse times cos of angle. So that becomes sine B cos A. And this side, which is opposite to the angle, that becomes hypotenuse times sine A. That would be sine B sine A. So we have here this length being identified as cos B cos A. We have this length being identified as sine A cos B. And similarly, we have this length being identified as sine B sine A and this length as sine B cos A. Now, since we have to find out the trigonometric ratios for the compound angle, we need the trigonometric ratios for this whole angle. So if I'm looking to find out the trigonometric ratio for A plus B. Okay, so if I have to find the sine of a plus b, sine of this angle, that's the compound angle, sine of a plus b would be perpendicular upon hypotenuse. So sine of a plus b would be this upon 1, or in simple words, that's going to be just this length, which is the sum of this length and this length. So I can say that sine of a plus b must be equal to sine a cos b plus cos a sine b. So this is going to be one of the compound angle formula, which tells me that sine a plus b is equal to sine a cos b plus cos a sine b. Similarly, if I have to find cos of a plus b, that is based upon hypotenuse, so that will be this upon 1. So I can say that if I find out this length, that would be cos a plus b. Now, if I want to find out this cos of a plus b, if I look at it closely, that will be this whole length minus this length. This whole length is cos b cos a, and this length is equal to this length, which is sine b sine a. So I can say that cos of a plus b is equal to cos a cos b minus sine a sine b. And that's how I get the other compound angle formula. So sine a plus b is equal to sine a cos b plus cos a sine b, and similarly cos of a plus b is equal to cos a cos b minus sine a sine b. Just you have the formulas for the sum of the angles, you can use these formulas to get the formulas for the difference of the angles. For that, first of all, you need to identify that cos of minus b is equal to cos b, because in the fourth quadrant, the minus b would lie where cos is positive. Sine of minus b is minus sine b, because in this particular quadrant, sine trigonometric ratio is negative. And similarly, tan of minus b should be minus tan b, because that is also negative in the fourth quadrant. So to be able to prove the formulas for the negative signs, in these positive formulas, I'm just going to replace b by negative b. Everywhere you have a b written, you can replace that by negative b. So sine a minus b, it becomes sine a cos of minus b plus cos a sine of minus b. And then we would recall that cos of minus b would be positive, so it doesn't make any difference, but sine of minus b becomes negative, so there would be a negative sign over here. That gives me the formula for sine of a minus b. Similarly, if I need to know the formula of cos a minus b, in this formula, everywhere I have b, I'm going to replace that with minus b. So this becomes cos a minus b, this becomes cos of minus b, and this becomes sine of minus b. Cos of minus b becomes positive, and sine of minus b becomes negative, and negative negative becomes positive. So that's how I get the formula of cos of a minus b. So I have a formula of sine a plus b, cos a plus b, sine a minus b, and cos a minus b. We can use these formulas to further derive the compound angle formula for the tan ratio, where we just need to recall that tan is sine over cos. So that means that tan of a plus b must be sine a plus b divided by cos of a plus b. So if I divide this by this, I will get tan of a plus b. So that would be this whole thing in the numerator divided by this whole thing in the denominator. And to express it in terms of tan ratios, I will divide both the numerator and the denominator by cos a cos b. Because if I divide both numerator and denominators by the same expression, obviously it still stays equal to the same original thing. So dividing this by cos a cos b and this by cos a cos b to make sure that the entire numerator is divided by cos a cos b, and similarly dividing this by cos a cos b and this by cos a cos b as well. Now once I look at this and this cancels out, sine a over cos a becomes tan a. Similarly, this and this cancels out, and sine b over cos b becomes tan b. Here all of the terms are cancelling out, so it will be 1. Here nothing is cancelling out, but this sine a over cos a gives me tan a, and this sine b over cos b gives me tan b. So once I have the formula for tan of a plus b, I can use that very formula to get the formula for tan of a minus b as well. I'm just going to replace everywhere that I have b, I'm going to replace that with minus b. So it becomes tan of minus b and tan of minus b. And then we'll recall that tan of minus b is negative tan b. So this minus comes out, it becomes tan a minus tan b, and this minus comes out and it becomes minus minus plus, so it becomes plus tan a tan b. So these are the four compound angle formulas that you have for sum of angle sine a plus b, cos a plus b, and tan a plus b. And similarly, you have formulas for sine a minus b, cos a minus b, and tan a minus b. And also please note that these formulas are going to be given to you in the formula sheet for P3 exam. It's just that you need to know where the formula comes from, so that if some step might require to derive these formulas, you know where they come from. Now moving on, you can use the same compound angle formulas to prove the double angle formulas as well. So looking at this formula of sine a plus b, which is sine a cos b plus cos a sine b, I am replacing b is equal to a. So in place of b I got a, in place of b I got a, in place of this b I also got a. This becomes sine of a plus a, that is sine 2a. This becomes sine a cos a, and this also becomes sine a cos a. Obviously, if two quantities are multiplying, then it doesn't matter in what order I write them down. So sine a cos a plus sine a cos a adds up to 2 sine a cos a, and this is your double angle formula for sine. Similarly, you can get a double angle formula for cos as well by again using that very formula that you have as a compound angle formula and replacing b by a. So this becomes cos of a plus a, cos a, and sine a sine a. So cos 2a becomes cos square a minus sine square a. This is one form of it, but you can also rewrite it into two more forms, recalling that sine square a plus cos square a is equal to 1. So you can replace sine square by 1 minus cos square. You can also replace cos square by 1 minus sine square. So if I replace sine square by 1 minus cos square, this simplifies to 2 cos square a minus 1. And if I replace cos square a by 1 minus sine square a, it becomes 1 minus 2 sine square a. These are very, very important formulas, the double angle formulas. But yes, as far as cos 2a is concerned, you can rewrite into 3 different forms. Similarly, if I have to prove the double angle formula for tan a plus b, I can start from the compound angle formula and again replace b by a. So this becomes tan of a plus a, tan a plus tan a, and 1 minus tan a into tan a. Tan a plus a becomes tan 2a, tan a plus tan a becomes 2 tan a, and tan a into tan a becomes tan square a, and hence you get the formula for tan 2a as 2 tan a over 1 minus tan square a. So you have a double angle formula for cos 2a, you have a double angle formula for sine 2a and tan 2a. Again, I would like to highlight this one thing. All of these formulas are going to be provided to you in the formula sheet in Math P3 exam, but you need to know the source or the origin behind how these formulas are actually being derived. Thank you so much everyone. I hope you liked the videos, and I hope it was clearing your concepts about how your compound angle formulas or your double angle formulas come, which you can use further on for more proving of trigonometric identities, which I will be discussing in the next video. Thank you so much. If you found this video helpful, I will be uploading more such videos, and I would really appreciate if you subscribe this channel.